Now that I have the Boston Dynamics spot responding to teleoperation from the Apple Vision Pro, next thing I want to do is incorporate a few of the things that I have either working on the Vision Pro side, meaning like the natural language processing, to things like context understanding and implementing functions and agents and all those kinds of things that I can already do in the Vision Pro. And I want to take the Boston Dynamics spot and integrate it with that. Eventually, we're going to bring all this into a cloud component, cloud server. We want to get there one day. But for today, what I'm trying to do is implement this top half here in its entirety, not today, but we're going to get to most of this. A lot of this I've already built in various forms, but I'm going to concentrate on item number 7 here, which is get current location from input. And I want to do it in multiple ways. First way is I want to get the 2D camera image from the Boston Dynamics spot from its various cameras, and then say, okay, you lock on to the goal if the goal is present. So now I'm going to look at all 6 cameras or all the cameras around the spot and say, okay, am I reaching that goal? So if I say I'm in a room like a bedroom and I need to be in a bathroom, then I'm going to look at all 6 cameras and find the door and go out of it. That's probably the best thing to do in that particular case, or go to a door if it's open. If I'm in the bedroom already, and let's say I'm looking for a sofa, one of the camera's images has the sofa, I want to then orient myself, the spot to the sofa. And that will be a process of understanding which camera I'm in, and then also the orientation. So that was a lot of talking. Let me show you what I've done, and first let me show you where the inspiration came from for this part of the project. First thing is, Spot has a bunch of cameras, and those are quite awesome. But and the Spot also has this 4K gimbal camera on the top that we looked at in the last video. What we're going to do is kind of ignore that 4K camera, because I'm building an upper half of the Spot myself that has all the things that I want on it. But for today, I'm going to look at all 6 cameras images while the Spot is stationary and make a decision. And then after the Spot has reached a short-term goal, I'm going to do the same thing again and again in that process. Obviously, we need an e-stop, which is why you see a line here that says, create an e-stop. That's probably important, because we want the Spot to kind of indefinitely run around, not finding its goal, and then just also not finding anything. It won't run into walls, so that's great, but it definitely will not find its goal. So here, looking in llama-index, found llama-index's version of structured outputs for LLMs, and that's kind of the title of what we're looking at here. And here's an example, multimodal example using the same. There's lots of different examples out here like this, but here's one in which here's an image that's been input, and you can see here the total price is $873, not $1073. And using OpenAI's output, was able to find that the price was $873, and this is an 8-piece wings or chicken poppers, and it's the Black Friday offer. The input here is the image, and the output format is this class restaurant here, restaurant food, discount price, ratings, review, and I could do more if I wanted to. I could say like something that's obviously in the image that, say I wanted to say, if there is a special thing with an asterisk, then describe that. I can say like special description or something like that, and then it would naturally try to find and stuff something in this box if possible. So here you see there's no ratings or reviews in this image. No ratings or reviews. And if you look down at the results, not specified, not specified. So this is exactly what we want. We want structured output. We know that OpenAI now includes structured output, but we really don't want to just support OpenAI. We want to support whatever might come out, Claude, Llama models using Llama 3. So a generic way of looking at that is kind of what we just looked at, using Pydantic, and then here's just one using Instructor, which I also like to use as well. And then here's another one by want to give everybody their credit, David Min, who used Bedrock Anthropic, which is, I guess I work for AWS, so that's probably the preferred example. But in this case, we're trying to show the functionality. It doesn't matter which one we use. Okay, on to the goodies, the code here. So first thing we're going to do is we're going to get llama-index. We're going to bring in our includes, which includes Pydantic, and the ability to find the path, or we can use import OS. In this case, we're just going to find the path to the directory, and then we're going to get the file in the directory, the image that we're looking for. We're going to print it to the screen, and then from there we're going to get a response back, in this case from OpenAI. I'm a bit concerned about the time of the response from OpenAI, but there are other models that perform faster but not better. So in this particular case, this is the model I used. So you can see here, I'm going to run it a few breakpoints here so you can see that things are happening. I'm getting a file, and here's a file. This one is actually not a image from one of the cameras. I was just trying to make sure this works. Okay, and then once we have that, having trouble closing this window or shrinking it down. There it is. All right, took forever to shrink. Probably has something to do with QuickTime. Okay, so now then we're going to get the response from OpenAI, and then we're going to print that response. So you can see here, down in the bottom here in debug, it was able to classify the sofa. It's in the living room. It's to the right, as in I asked in the prompt to treat the picture as the camera. And the size of this is probably about 2.5 meters, it's estimating. And the distance from the camera where the image was taken to the sofa is about 3 meters. So this is great. If we can get this consistent results, and let's make that bigger again so we can, and actually let's just step through the code so you can see it just kind of prints out one by one the various things we've asked it to print out. And so this is just being pushed into that class. Now that class is usable. You can see the results here are quite good. It's perfect. It's exactly what we need. And so I can take this and iterate over my, my image folder that I'm automatically creating every single time that we get images. So here are some that from the camera. Some fisheye images. They're kind of boring because I'm taking them every basically every frame that I can take an image, I'm taking one and storing it. So it's super boring, some of these images, but others are, you can kind of see the outline of something in there. But they're quite useful images coming from the spot. So that's, and so here's the back of a chair or something like that. You can see that they're not very bright, which is something that I'm gonna have to work on. I'll work on the, masking and those kinds of things to make this all better looking and maybe smaller. But the better idea that I have is to use not only these images from the spot, but also a custom camera or camera from Luxanis called the Oak D Pro, which has 4K. It has a bunch of classes already defined that I can iterate over Amazon Q and bring those into my code base very easily. So that's the plan. The next step from here is to, among many steps, is to work out a little bit of an experience, a physical embodiment of that camera, probably on some kind of gimbal that I can control with speaker system and microphones, those kinds of things, and maybe a few other sensors. Put that on Spot's back and then use that as the primary camera to identify objects. But the secondary backup system will still be these other cameras that the Spot already has. And we can use those with these images on an interval as Spot reaches a goal, let's say we will kind of reassess and reassess and reassess. Is OpenAI the right place for that? Probably not. We probably need to find a model that performs well, and that's the point of this test harness, is to kind of look at all the various models. But anyway, good enough for now, and we'll talk to you next time.